Going to go over the transformations of our linear equation. So remember, depending on what your slope is or what your y-intercept is, that can change the line, right? We know that our parent function just has a slope of 1, starts at the origin, right? 0, 0. But any changes that are made to slope or y-intercept can move it from that place. First of all, we have what we call vertical compression. So vertical compression is going to happen when your graph is getting flatter. Okay. This just means graph is flatter. So if my linear equation is here, okay, and I change the slope to make it flatter, that means it looks more like this, right? So it was here, now it's a little bit flatter, not increasing quite as much as it was, okay? So that would mean that something happened to our slope, right? That means the slope's value has decreased. This has nothing to do with there being a negative, right? It just means the slope got smaller. So we know for our parent function, the slope is 1, right? So what's a number that's smaller than 1? 0.5, 0.05, right? So anything that's smaller than 1 when we're talking about slope just means it got smaller, as in maybe like a decimal or fraction. It doesn't have anything to do with negatives. Negatives do something else. So when we say that the slope got smaller or less value, it just meant that the number itself got smaller, not that it has a negative sign. So we say that the slope's absolute value decreases. So remember, with absolute value, that's going to keep anything from being negative, right? So we're only concerned with that number's absolute value as to if it got smaller or not. All right, so vertical compression means it gets flatter. A vertical stretch would mean that it's getting steeper, right? So this means the graph is steeper. And this is again determined by your slope. So for it to get flatter, if your slope's absolute value decreased, for it to get steeper, your slope's absolute value should increase, right? So slope is what determines the steepness of our line, whether it's getting flatter or steeper. Okay, now we're going to talk about how you can reflect a graph. So typically, if I asked you to graph an equation, if it's got a positive slope, it slants this direction, right? But we know that if it's a negative slope, it automatically is going to be graphed in the other direction. Okay, and this is going to be determined by some type of reflection. So if you are reflecting across our x-axis, which is what really is happening. I know it doesn't seem like it. It seems like it's going across the y. But basically, we flipped the points, right? The points that were up here end up down here. The points that were down here end up here, right? So we are reflecting across the x-axis. And what this does is all of your y coordinates change to their opposite. So if it was a point that had a y value of -6, whenever it's reflected, it's now going to have a y value at +6. But all in all, as we know, what this really means is that there was a negative in front of our slope, right? So it's what happens in front of slope. So your slope becomes opposite. Not opposite reciprocal, but just opposite, right? Okay. And then last we have what we call translations. So translations, unlike changing the steepness of our line or the direction of our line, it actually picks our entire line up and can move it up or down or potentially even to the left or to the right. So it won't change the steepness of the line, just the location of the line. So here, this is when your graph moves up or down or left or right. The one thing that doesn't change here is your slope. Your slope would stay the same. It's that y-intercept, or the piece towards the end, that is going to be changed. So slope doesn't change. Now, typically with a linear function, we're going to see things move up and down, right? Because the y-intercept in our equation determines where it starts on the y-axis, which is what moves it up and down. With our linear functions, we don't see near as much left to right movement. So we're going to add one more on here about how the y-intercept increases. Y-intercept increases, the whole graph goes up. While if our graph if our y-intercept decreases, the graph goes down. Let's see. Okay, and then real quickly, we're just going to graph some examples of these different types of changes so we know what it looks like when we apply it to an actual graph. All right, so we're going to first start with our parent function. Okay, as we know, the parent function has not been moved up or down, and its slope is as basic as it gets, right? Up 1 over 1. So this is our parent function, y equals x. Starts at our origin, 0, 0, going up 1 and over 1 in the positive direction. All right, and then the first type of change we talked about up above was vertical compression. Like we said, that means our slope's absolute value is getting smaller, and you guys gave me several examples of that. You said like 0.5 or 0.05 or 0.25. Basically, anything that's smaller than this understood 1 value of slope would make it less steep than the current line. So we'll use one of the examples you gave, like that 0.5. Y equals 0.5 or 1/2 x. We typically like to see our slope written as a fraction versus a decimal. And this is going to show compression. So it still starts at 0, 0, but instead of going up 1 and over 1, it's going to go up 1 over 2. And as you can see, that line is compressed or flatter than the one before it, right? Okay, the next type of change we talked about was a vertical stretch, which we said means our graph is going to be steeper, right? So if I want it to be steeper than the parent function, I would just pick a slope that is larger than 1. Yeah, 2 works. So we could do y equals 2x. This is going to show a stretch. Again, starting at 0, 0, this time going up 2 and over 1. And then the last type of change, the next type of change that we mentioned was our reflection, right? And we said that this just meant that it changed the sign or the slope became opposite. So opposite slope of the parent function, again, we said opposite, not opposite, reciprocal, right? So all I'm doing is putting a negative in front of my slope. And this shows reflection. So we're still starting at the origin, 0, 0, but instead of going up 1 and over 1, I'm going down 1 and over 1 to the right. So it's the exact same line as the parent function, it's just been reflected. All of the values that were here have been reflected across the x-axis to down here. All the ones that were down here have been reflected across the x-axis to be up here. All right, then the last type of change we talked about was a translation. I'm going to go ahead and keep our slope negative just so that it doesn't get confused with the other 3 lines going the other direction. But we said a translation is going to move things typically in a linear function up and down, but potentially could also move left and right. We said if our y-intercepts increase, it moves the whole graph up. If it decreases, it moves the graph down. So currently we have not even had a y-intercept change, right? It's been at 0, 0, since we didn't have a number on the end. So if I put -2 on the end, this would show a translation of 2 units down. So now, instead of starting at 0, 0, I'm starting at -2. And it's the exact same as that line that we just graphed with a slope of -1. It just picked the entire line up and moved it down 2 units, right? Nothing changed about the line, just got moved down. All right. And obviously, multiple transformations can happen at the same time, right? Like here, we had it reflected and we shifted it down, right? Multiple things can happen in one equation. So hopefully this is a good enough review to help you with those 2 questions that were about transformations. Also, one thing, I think there is a question on that assignment that asks you to put your equation in standard form. We didn't go over that, but I'm assuming we remember that standard form is that ax plus by equals c form. So if there's a question that asks you to do that, all they want you to do is rearrange your equation, right? So if you had it written as like y equals -3x plus 2, and you wanted to write it in standard form, you would just need to move your 3x over here, right? So I would add 3x to the other side, and I'd have 3x plus y equals the 2 that was still over there, and that would be in standard. All right?